Hey everyone, it's Amir Ali. Welcome to Code and Cadet by Sam. In this video, we are going to break down the CQRS design pattern in microservices. Now don't worry if this sounds a bit technical at first, we'll start simple. I'll walk you through what CQRS actually means, why it's useful, and where you'll see it in real projects. By the end of this video, you'll have a clear understanding of CQRS without any heavy jargon. So let's jump right in. Alright, so here's what we are going to talk about today. First up, we'll look at what exactly is the CQRS design pattern, just a simple definition so it's crystal clear. Then we'll step back a bit and talk about the key challenges teams face when they don't use CQRS in microservices. You'll see where the pain points really show up. And finally, we'll see how CQRS actually solves those problems and why it can make a big difference in real-world systems. So yeah, by the end you'll not only know what CQRS is, but also why it exists and when it makes sense to use it. So CQRS stands for Command Query Responsibility Segregation. In simple terms, it just means we handle reading data and writing data separately. We use different models or different components for each side. And the benefit of that is this separation lets us optimize and scale each side independently. That means better performance and much clearer code, especially when we are dealing with complex or high traffic systems like microservices. Let's take a simple example of an e-commerce website. Right in the middle, we have got the product service. It handles all product operations, adding products, updating them, or showing them to users. On the left is the user. They interact with the website, searching for a shirt, browsing product categories, or placing an order. And on the right, we have a single shared database. That database stores everything: product names, prices, stock levels, and more. Now imagine a customer wants to buy a shirt. The request goes through the product service and updates the database to reflect the purchase. Everything works fine. For now, the setup is simple and effective, especially when the number of users is small or the load is balanced. But the real question is, what happens when the number of users starts growing rapidly, especially when most of them are just browsing products and not buying anything? That's exactly what we'll dive into in the next slide. Now let's move forward. As our e-commerce platform grows, the number of users increases significantly. All of these users are still interacting with the same product service, and that service is handling both reading product details and writing changes to the database, like when someone makes a purchase. Technically, the system still works. The product service continues to process requests and the database keeps storing and serving data. But this is where things start to get interesting. But here's where a subtle problem begins to appear. While some users are actually buying products, the majority are just browsing. They're reading product details, checking sizes, comparing prices, scrolling through categories. That means most of the incoming traffic is read heavy, not write heavy. And because the same service and the same database are being used for both reading and writing, this puts unnecessary load on the system. Operations slow down for everyone, even for users who are just trying to browse casually. If too many users start reading at the same time, it can even hurt performance for the ones placing real orders. So yes, the system is technically working, but it's not working efficiently at scale. And this is exactly where CQRS comes into play. By separating read operations and write operations, we can scale and optimize each side independently. Think about Facebook. Millions of users are online every single second. When you open Facebook, you're mostly scrolling through your news feed. That's a read-heavy operation. You're reading posts, pictures, comments, likes. Millions of users are doing this at the same time. But in parallel, some people are posting new updates, liking posts, leaving comments. Those are write operations, changes that update the system's data. Now, if Facebook handled both reading and writing through the exact same service and the same database, the huge number of readers would slow down the experience for the ones actually posting or interacting. To avoid this, Facebook follows an approach very similar to CQRS. They separate reading from writing, so they can scale reading the newsfeed independently from writing new posts or reactions. The result? Millions of people can browse smoothly without waiting for the few who are posting or interacting. Better performance and a much smoother user experience for everyone. Alright, let's quickly summarize the problem before CQRS. In traditional systems, the same service and the same database handle both reading and writing data. But here's the catch. Most users are just reading or viewing data, while only a few are actually writing or updating it. This mix creates performance bottlenecks because reads and writes are competing for the same resources. As user traffic grows, the whole system slows down and scaling becomes really difficult. And since you can't optimize reading and writing separately, the overall user experience starts to suffer. Now, let's see how we can solve this problem using the CQRS design pattern, which stands for Command Query Responsibility Segregation. Take a look at this diagram. We made an important change inside our product service. Instead of one big block of logic handling everything, we'll split it into two clear parts. At the top, we have the right side. This handles commands, actions like adding a product, updating prices, or placing an order. At the bottom, we have the read side. This handles queries, things like fetching product details, listing categories, or checking sizes. Now on the left, notice the users. A smaller group of users perform write operations like purchasing items or updating inventory. But the majority are just performing read operations, browsing, searching, or checking product info. With this architecture, read operations no longer interfere with write operations. That means browsing users don't slow down the system for people who are actually buying, and those placing orders can smoothly update data without being impacted by heavy read traffic. On the right hand side, we've also separated the databases. The write database is optimized for handling updates, inserts, and deletes. The read database is optimized for fast lookups and filtering. So here's how it works. Whenever a change happens, let's say a new product is added or an item is sold, it's first stored in the write database. Then an event bus sends out a message that something has changed. This event is picked up and used to update the read database so it always stays fresh and in sync. This design gives us three big advantages. High performance even with heavy read traffic. Scalability because we can scale the read and write sides independently. And most importantly, a better user experience, both for customers browsing and for those making purchases. So with CQRS, our e-commerce system is ready for high traffic, growing users, and smooth operations. If you like this video, please give it a thumbs up and don't forget to subscribe to this channel. Your little support really helps me grow here. And hey, press that bell icon too, because I'm going to cover all Java interview question topics from basic to advanced level. Thanks for watching. Then see you in the next video. Bye bye and keep learning.